Hi guys, welcome to this video. My name is Israel Godínez Castillo. I'm from Mexicali, Baja California, Mexico, and I'm studying currently 6th semester of mechanical engineer. We are going to create in this video analysis for our mid surface. Now we create a new database called mid surface, like you can see on the screen. After that, we select our tolerance based on model. We import our mid surface that I'm going to give you the file on the description of this video. And now we are seeing our summary. Click OK. After that, we have to associate the little cassettes on the model. So we put geometry, associate curve, surface. We rotate our model, so we have to select the edge on the triangle in the middle, and we have to do it for everyone. We are associating a Gaussian with in direction J with in direction Y, with the surface. So we have to do it for everyone. This is a little bit tired. I get tired doing this, and a little bit boring, but yeah. So we have to do it for everyone. So we continue selecting everyone. And as you can see, it's taking a little bit, so you must be very concentrated doing this, because if you associate something different, it's going to be very important for your analysis, for your analysis. So we are only missing two. So we rotate our model, our mid surface, and we select the last one. So remember, is a middle one with the surface, and we are missing. Oh no, we are missing two other ones. Sorry, I didn't see them. Because it doesn't associate, because I select a different curve. So now we're only missing what? Okay, I select another surface. Now we're only missing one. So we finish. We now have associate everything on every Gaussian with other parts. So now we have to. I save it because it doesn't appear a ribbon up there. So I'm going to reopen it. As you can see, it's the same folder, the W4. Sorry about the mess on my desktop. And now I open it again, and as you can see, we have the ribbon, the new tool menu right there that says geometry, elements, loads, materials, properties, load cases, fields, analysis, results, XY plot. So it's very important for our this is where we work. So if I don't have it, if we don't have it, we can't work right there. So now as you can see, we have there, and now we are going to create our mesh. So to create our mesh, we have to go to elements. You can locate elements up there. So elements, mesh, surface, now measure paver. We select all, and I like it a 9 right there. We have to select not too big number, like the measure the automatic calculation gives for us. I clicked it 2 times, so it was a mistake. Okay. I don't like it. I'm going to go back. Sorry. Okay. Well, I didn't go back. Okay, I'm going to create again the mesh, and I'm going to put 9, apply, so I have created the mesh. If you want to take a risk, you can reopen it, so it doesn't happen anything. And now we are going to click on equivalence, apply, so we delete the repeated nodes. Now we click on verify. We can action verify object element test boundaries. So we have to see this on our screen. And now we are going to put a load. So we go to action to loads up there, create total load, like the set name, target element type. You have to make sure it's 2D. Input data is the magnitude of our load. So remember, it's edge load. Okay, a lot of people make a mistake, like myself. The first time doing this, I go to surf load, but no, it's the other one. So now we select where we want it. We want it on these little holes in this surface. So we are going to select edge, add, and we're going to add one by one, so we cannot make a mistake. We are not going to make a mistake selecting our little holes. It's very important. It's where the force is going to be on our analysis. So now when we have these 4 loads, we click apply, and as you can see it on the screen, the blue ones right there in the next side of the holes. So now we're going to create a displacement. We are going to call it fix it. Why fix it? Because we're going to fix the base. We're going to fix the base so we can analyze it well. We're going to put translation and rotation 0, 0, 0, 0, 0, 0, because we don't want that our mid surface moves. So it's going to be fixed. From where? From the 4 little holes on the base. Now we are going to see it. Select geometry entities and those ones. We're going to select those ones one by one, so we don't make a mistake. Very important. Okay, one by one. The last one. Okay, fix view. The last one now. Add. Okay. And we click on apply. So you can see the blue little forces appear on the screen. Now we're going to create a material. Create isotropic manual input, material name, aluminum. Input properties. We're going to click on input properties. Elastic modulus, we want an elastic modulus of 10 E6 and 0.3 position radio. We click OK, we click apply, and now we have created our material, as you can see down there. So now we're going to create a set name on properties to create a shell. So create 2D shell as a property set name, Then we're going to click on input properties, and here in material name we're going to select the previously created material as aluminum and thickness 1.125. You have to make sure it's thin, homogeneous, and standard formulation. We have to where we want this material in all of the surface. So we select all of the surface, add, OK, and then we have to click on apply. You have to click on existing load cases, and we see it, and type static, everything's fine, there's nothing weird right there. So we click on analysis. Don't be desperate. We select solution type, we have to make sure it's linear static, OK. Now we go to translation parameters. It's everything, just a little bit check, nothing weird. Subcases, we have to make sure available load cases default. We selected just for the dubs. Subcases select, again we select default. Sorry, default. sorry. OK. We go to apply, and we are waiting to Patran to make the file so we can analyze it in Nastran. So we open Nastran, select mid surface BDF. You can see I have it in the same carpet, W4, so run. And now we have to wait. Don't be desperate again. Is a little bit it lasts a little bit, so we have to wait it ends. Usually you click a beep in your computer, so it finishes. I hear it, so I'm going to click actual results, XDB. So we have to make us sure that in our F06 file we can edit it with Notepad or with another text edit. We don't have this word right there fatal, so Control F, we look for fatal, it doesn't appear. So now actual results, attach bit XDB, we select the results mid surface, we click apply, so the file is attached. So now we are going to see how the Nastran analyze it. So we're going to click action, create, deformation in results. Make sure it's results. We select default and displacements translational, and now you can see it how it moves our mid surface. Now we are changing some of the presentation of the results, and you know we can play a lot with the way we can see the results. So we're going to erase the ones we had, and we're going to make a new plot. So we're going to select fringe, create fringe, stress tensor, quantity bond misses, position at 0.1. As you can see, apply, and these are going to be the results. As you can see, the bigger stress is at the holes fixed in the the points that are